over 2 questions over stoichiometry, just to give you some examples to follow along to do your independent practice with. All right, so first thing that we're going to do is going to read our question, and we're going to underline the important information they give us in the problem, and then we're going to box what they ask us to find. So assuming that 8.5 liters of iodine gas, which is this one right here, are produced at STP according to the following balanced equation. I want to know how many moles of potassium iodide, which is this one, were used. So I don't need this guy, I don't need this one. First things first, you always want to start by writing down whatever number they give you in the problem. So the number they give me is 8.5 liters of iodine gas. We will then draw an arrow to what they are asking us to find, and that's what we put a box around. So they ask us to find X moles of potassium iodide. Right. Next step is we're going to take the units that we have here and you're going to drop them down. We're going to create a second line. We have liters of I2 or iodine, and we have moles of Ki. Next, I need to use the coefficients in the balanced equation that they gave me. So I look here, I have I2 here. I go up and I look for I2. Here's I2. The coefficient in front of I2, there's nothing there. So it would just be a 1. So we'll have 1 times something. And then I'm going to look at Ki. And in front of Ki, you have a 2. So we need to do 2 times something. Now it's time to fill in my blanks. So in order to fill in my blanks, you need to look at whatever units they give you in the problem. Over here, we have the L for liters, which measures volume. Liters is always going to be 22.4. So anytime you see liters, 22.4 is going to go in that blank. Over here, you have moles, and moles is always going to be 1. Now that the blanks are filled in, we can go ahead and we can do some of our calculations. So when we do 1 times 22.4, you just get 22.4, right? Because 1 times anything is just itself. And then you do 2 times 1, again, 1 times anything is just whatever that number was, so it'll be 2. So we have that. Now that we've done our multiplication, we can cross multiply and divide. So in our calculators, we're going to put 8.5 times 2 divided by 22.4 and press enter. And you will get 0.759 moles of Ki. That will be your final answer. All right. Moving on to our next one. So the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. The reaction is run using 751 grams of ammonia, that's this one, and excess oxygen. Excess just means extra. So how many moles of H2O are formed? All right. So write down what they give you, 751 grams of NH3. Draw an arrow to X. They asked us for moles of H2O. We're going to take our units bring them down. So grams of NH3 and moles of H2O. All right. So now let's go get our coefficients from the balanced equation. NH3, ammonia, has a 4 in front of it, so we're going to have 4 times a number. And then H2O has a 6, so 6 times some number. Now let's fill in our blanks. When we see grams, we're going to use the molar mass of whatever the compound is. So grams of NH3 means I need to calculate NH3. So we have nitrogen and hydrogen. We have 1 nitrogen and 3 hydrogens. And we're going to multiply by the mass off the periodic table. So nitrogen's mass is 14.007. Hydrogen's 1.008. Do those calculations. 1 times 14.007, and then 3 times 3 times 1.008 gives me 3.024. And then we're going to add these together to get 17.013. This is the number that's going to go in our blank. Now, over here, you have moles. Moles is always 1. Go ahead and do our math. So we'll do 4 times 17.013 to get 68.052. I'm going to mark this out because I don't want to get confused with any of the extra numbers. 6 times 1 is 6. Now we cross multiply. So whatever's in the circle, we multiply together, divided by the number that's out here. And so we get 66.2. Moles H2O. And that is it. Just remember, the biggest thing to remember is don't forget about your coefficients from the from the balanced equation. And then also make sure that if you ever see moles for the second line, for the second part down here, right, for this line, moles will always be 1, liters would always be 22.4, and grams will be the molar mass that you calculate using your periodic table. Now you may go ahead and move on to your independent practice.